Chapter 5, Section 2, Grandmaster, Critical Thinking Problems. Number 1, express each surface area formula in factored form. So we're actually going to do a little bit of time traveling. We're going to have a look at some of these formulas that we would have seen in Chapter 2. This was the surface area for a square pyramid and cylinder, etc. And all I'm going to do is the expression on the right, I'm going to factor it as best I can. That's all I'm going to do. So I'll just look for a GCF. So both of these terms contain a b. That's the best I can divide out. So that leaves a b plus 2s in brackets. All right. So this is the formula for the surface area of a square pyramid, but it's just in factored form. And that's all there is. Looking at the surface area of a cylinder, okay, this has 2 pi r squared plus 2 pi rh. There's actually quite a bit we can factor out. Looking at the coefficients, I can factor out a 2. Both terms contain a pi, so I can factor out a pi. This has an r squared, this has an r, so the best I can pull out is an r. And this is the only term that has an h. This one doesn't, so I can't factor that. So let's just write out what's left. There's still a factor of r trapped, and then the h is left over. Okay, so again, this is the surface area of a cylinder in factored form. And the surface area of a rectangular prism, just a closed box. All right. Looking at each term, I can factor out a 2, definitely. And, well, I can't factor out an L because the last term doesn't have one. And I can't factor out a W because the middle term doesn't have one. Well, in fact, that's all I can factor out is that 2. So this is LW plus LH plus WH. Remember, none of these terms are like terms because they don't match. But I can at least factor out a 2. And if you ever look up the formula for the surface area of a rectangular prism, you might actually see it written in this form. I've seen it before. Question 2. 5 circles of radius r fit perfectly inside a rectangle. Part A. Write a factored expression to represent the shaded area. Okay. Well, I'm not going to worry about this factored business. I just want to come up with an expression in any form that gives the area of the shaded region. Once I have that, then I can factor it. Okay. Well, first of all, we need to figure out how to determine the shaded area. So the area shaded would just be the area of the rectangle, okay, minus the area of the 5 circles. Okay, that's no problem. Well, how do we find the area of the rectangle? There are no numbers given. Well, we're actually not asked to work with numbers. We just want an expression, and the only variable we have is r. So everything we have is going to be just in terms of r. Remember that the area of a rectangle is just the length times the width. This is r. Well, it's a circle, so that is r. So is this. So is that. And this. Let's put a little dot for the center, and so on. And you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this length is 10 radii, or 10r. Okay, and the width here, okay, well, that's a radius, that's a radius. I have 2 of them. So this is 2r. Okay. So to find the area of a rectangle, just multiply these together. So 2r times 10r is 20r squared. Okay, so that's the area of the rectangle. And then I need to subtract the area of the 5 circles. Well, recall that the area of one circle is just pi times its radius squared. But there are 5 of them that we have to subtract. So we're going to subtract 5 pi r squared. Remember, pi r squared, that's the area of one circle, and there are 5 of them. So I'll just write this down here. The area, the shaded region that I'm looking for, is given by 20r squared minus 5 pi r squared. So that's an expression, okay, okay, on the right-hand side here for the area. And we just want to write it in factored form. I would argue that's the easiest part. Look for a GCF. 25. Well, the best I can do is a 5. R squared. Hey, that has an R squared, so I can pull that out. And well, that's all I can do. So what's left over from this term? A 4. And from this term was a minus pi. Okay? And if you want to check, you could multiply these out again and you get this back. Okay, so this is my expression here on the right in factored form for all this gray stuff. Part B, what percentage of the rectangle is the shaded area? Why does the value of R not matter? Okay, well, we just want to find this shaded area here as a percentage of the entire rectangle, which was the 20R. So we want the area of the shaded region divided by the area of the rectangle. And then as a percentage, we just multiply it by 100. Whoop. Okay. So this gives me, what do we have? I'll leave it in factored form, and you'll see why it was useful to write part A in factored form, because when we do the division here, something nice happens. Okay. And the area of the rectangle, okay, that was 20R squared. Okay. Well, I hope you can see that R squared divided by R squared, that's just 1. They cancel. So the R's are, well, irrelevant now. And then 5 over 20, that's reducible. Okay, this is 1, this is 4. Okay. All right. So here I'll put in that times 100. Haven't worked it out yet. So this gives me 4 minus pi divided by 4 times 100. So I'll take my calculator. I know I'm going to get a decimal. So 4 minus pi equals, okay, make sure you hit equals, then divide it by 4, and then you multiply it by 100, and you get approximately 21.46%. Okay, so that's the answer to the first part. And lastly, we have to explain, why does the value of R not matter? Well, when we actually got this result from here, there was no R because they canceled out completely. So the radius could be as small or as large as you want, but when we work it out as a percentage, it doesn't matter. It's completely irrelevant. Why is that? Well, think of it like this. If you have a small circle and a bigger circle, and I cut them both in half, and I say I shade one of them, one of the halves, and I ask, what percentage of the circle is shaded? Well, it doesn't matter how big or how small the circle is. I've shaded half. So this would be 50%. This would also be 50%. So the radius of the circle doesn't matter at all. Same idea here. Number 3, solve for x. Hint, you will need to factor. Okay, remember, when you're solving, what you're doing is you're isolating, meaning if we want to solve for x, we just want to do whatever we can to this equation here to get it by itself. Okay, this is an equation because I have an expression on the left set equal already to something else on the right. So I have a left side and a right side, and whatever I do to one side, I must do to the other. So this is an equation. But we want to get x by itself. Well, this term contains an x. This one does not, and then 2xy on the right does contain an x. So in this technique, I'm going to gather all the terms that mention x on one side, and any terms that have nothing to do with x, express them on the other side. So this 5x I'm going to keep on the left. Okay, and this negative y, I'm going to get rid of that. So I'm going to add y to both sides. So that gives me 2xy plus y. Plus y. And now I want this 2xy on the left, so I'm going to subtract 2xy from both sides. Okay. Now these terms on the left, they are not like terms, so don't start combining them. Okay. There we go. All right, so now I'm going to factor because this contains an x and that contains an x. So I have 5 minus 2y equals y. Now x is only written once, and I was able to do that because I could factor it out of these two terms. And I will now divide both sides by 5 minus 2y. And what happens on the left? Anything divided by itself, except for 0, is 1. So I'm done. I have x equals y divided by 5 minus 2y. So I just took this original equation and rearranged it so now x is by itself. Let's do another one. Again, we want to solve for x. I have an expression here on the right containing an x. This has nothing to do with x, but I have an x kind of buried within this set of brackets. Okay, so I'm going to use distributive law. So I get 3y minus 3x minus 4 equals xy squared. Okay, so the goal is still to solve for x. So I'm going to collect all the terms that mention x on one side and all the terms that have nothing to do with x, put them on the other side. So this negative 3x will stay. Okay, and I'm going to subtract 3y from both sides, and then I'm going to add 4 to both sides. So they will effectively disappear on the left. Okay, it's important to remember I didn't move them. Okay, I added and subtracted from both sides. I just get 0 here. But then this term on the right had to go somewhere. I subtract xy squared from both sides. So it disappears on the right, hence why I didn't write it. But I had to subtract it from the left as well. Okay, so it's just like I did over here. I just didn't show the little writing up above. Okay, again, there are no like terms here, so don't start combining these. But I can factor out an x on the left. And this is minus y squared. And again, that's still equal to negative 3y plus 4. There we go. And now I will divide both sides by this mess here. Whatever you do to one side, you must do to the other. Okay. And of course, this cancels because it becomes 1 over 1. So at the end of the day, x is equal to negative 3y plus 4 over negative 3 minus y squared.